Hello everyone, my name is Schwaighofer. I'm really excited for the opportunity to be giving this talk to you today as part of Conflang 21. I'm a PhD student at the Institute of Networks and Security at Johannes Kepler University in Linz, Austria. My institute currently has a research project called Digido, where we work on digital authentication in the physical world. So we do need a lot of security assurances for that. And this is one of the reasons why I'm very interested in technology that puts together software and systems in a way that is auditable even by the public, where a device communicates what software it's running, and there are mechanisms in place that force the device to be honest about that information. And this is also the focus of my thesis. So if this kind of thing is interesting to you, I would be really happy if you could reach out and we could have a chat about that. My email address should be visible on the screen. So thank you very much for taking a look at my talk, and let's start. Today I want to actually talk about another aspect of my job, which is on its surface unrelated. So part of my job at university is teaching a systems programming course. We have about 180 students each year, and this talk is about my attempts of further automating that course and teaching that course while also learning more about NICs. So this is going to be an experience report. I don't have any deep insights or great solutions that I want to share, but I want to talk about a number of specific problems that I ran into because I think they are worth talking about. Maybe some of them can be easily solved in a way that I totally missed. It's absolutely possible. It would be a big win for me if that was the case, because then I get a solution to my problem. Maybe some of them are problems that other people have seen in other contexts, indicating that they might be worth looking into more in the interest of making user experience better with NICs. So that's another possibility, and also very likely some of them are issues that are just specific to my use or misuse of NICs, and not just to building software in general in a less adversarial setting than a classroom. So maybe that's possible, but I don't think that I can make that determination, and this is why I proposed the talk in the first place, because I thought this would be a good thing to talk about in a group. So before we talk about the specific problems that I encountered, I want to take a step back and first look at the starting point from where I started. So what was the state then, and basically the specific things that I have been working on, so that you have an idea about what my motivation is and what the goals are that I'm trying to accomplish, and why I run into these specific things in the first place, because I think that's important for context. And so I want to get into that. You can see our course in Moodle on the screen now. Moodle is the web application that the university uses to organize courses. We do provide a VM for students to download and work on assignments so that there is some common defined environment. During COVID, we also started providing video lessons, as you can see, as a replacement for in-person teaching. At the bottom of the page, you can see the first assignment, which is due in a few weeks. And these assignments are basically the main thing that I want to talk about. So students work for multiple weeks on one individual assignment, and then we give out the next one basically. And for grading, we have a test framework that someone wrote at some point. We use that to write tests for the assignments that we give out, and then we give the tests and the assignments that were handed in. We pass them on to tutors that we have for this course, luckily. So the tutors then do the grading and look at each individual assignment, run the tests for each individual assignment, and basically use the test as a starting point and then look at the assignment manually. And so the tutors have to use the same VM as well, otherwise they wouldn't get the same compiler warnings, for example. And and that's part of the grading. Now I want to show you some of the improvements that I've been working on. So the first thing here is this form. I would imagine this to be a web service, but it's just a static page here with a web service that's a proof of concept for it. And the idea is basically to have this hosted somewhere, and while students are still working on their stuff, or every time that they try to submit something, they already get feedback for it without having to go through this long feedback cycle of somebody actually looking at it. And this would turn up things like compiler warnings, maybe run a test case or two, and give feedback if something's wrong there. And how it works is you can select a file here, and now I have to first start the thing. So if we look here, there's the Go code that powers this, and the relevant thing is this. So we use nix run to evaluate this single assignment, and we attach standard output and standard error to this flushed writer, which then writes it out so that it appears in the student's browser window. And the front end is just this HTML page, but would be something different, of course. But the main point is the web service. So if I now pick a file here, which I already did, and then I press submit query. All right, I gotta start the service, right? So I run this, and now I pick the file and I submit query. And we see that there's a build going on, and there's output that's scrolling down here live with what's actually being built, and this is the build output basically. And yeah, of course this is just very raw output, but you can see here that I actually ran all of the test cases, and they all passed because I just submitted the reference solution in that case. And yeah, that's the first thing. Now another thing that I did is write some Nix code that goes through the grading process for all the students and then produces an output where all of the tests have been run for all of the submissions, and then this is what we give to the tutors. So I already did this last semester. So instead of the tutors running the tests, they would actually already get the results and work with that and have that as a starting point, which is, I think, nice. Let's run this here. Let's start running it. Okay, so now this goes through all the students, builds all of the assignments. And now that this is finished, I have a result folder. So I'm actually not going to show the results because they have some personal data in them. But there is a folder with the student's name for each individual student, and there is everything they submitted and the test results. And basically I can take this whole results folder and put it in a zip file and then send it to the tutors, and they do their corrections there and then send it back to me. And eventually the idea behind it is to have some CI-like workflow where all of this goes together, not on my machine, but in some CI pipeline, and does all of these evaluations, and then tutors can add their corrections, and then it packs this all up together so that it can be updated in Moodle. The last thing that I want to show here is about the virtual machine. We can see here that there's a section about self-updating. So it says this VM is generated from and updates itself to the state of this repository. And so this is a NixOS image, actually a VirtualBox image with NixOS on it. And this is the configuration that's part of that image. We can look at the main file here. It has a description of all of the packages that are installed and things like that. this also has a self-updating service, if I find it. So this auto-upgrade service is something that Nix Packages provides, which is a systemd service that every 10 minutes updates itself to the state of some GitHub repository you provide. In this case, that's this repository. And so if something is wrong with the VM that we originally handed out and we have to fix some issue, we can actually do that on the fly for a bunch of cases that could be wrong. Actually had to do this last semester already, and it worked out quite nicely. But of course, there are things that you couldn't fix with that. It's interesting to me as an approach. So it's probably, of all the things that I'm showing here, the one that's most related to my research interests, where traditionally you would hand students a VM, or that's what we did before, and they have to trust you to not kind of put malicious code in there, or code that does things like spy on them, something like that, right? You could imagine that would be a concern for students. If somebody tells them, hey, work with this VM, they don't know what's actually in it, right? And with this approach, well, it has this self-updating capability, which is kind of problematic because it does always update to this target stage. And if I put something bad in that target stage, that's an issue, of course. So I won't go into that right now, but when it comes to the actual initial image, and having tampered with that somehow, so with the actual, just having tampered with the initial image as an alternative to downloading the image we provide, they could actually just start from the same description and go through those steps to build that same image. And then they would have the same output that we claim we are using, and they could just use that instead of downloading it from us, right? And I think that is a really interesting approach. And finally, these descriptions, there's also a log file in here, and this log file has specific commits for all of the inputs that it depends on, like Nix packages, for example. And so all of the descriptions that are in this main file here are very precise. They are for specific versions. And this is actually what we use in the other things that I showed to define the used version of the tooling, right? So we just have this VM as an input in our other files, and that way we get the same version of GCC and so forth. And also the live grading and the bulk grading is what I'll call it right now. The live grading and the bulk grading, those two also reuse the same basic building blocks for building assignments and testing assignments. So you would expect them to give the same results. Of course, the inputs are different, so you have to account for that in how you write the code, and there could be differences because of that. But it's underlying, it's the same tooling. Okay, now I want to get into the specific issues that I ran into while I was working on this stuff. Okay, so I actually now want to show you some code, and as a basis for that, I'm first gonna show you a working example that does something simple, and then we're gonna build on that for all of the things that I want to point out, for all of the issues that I want to point out. So this is a working thing that actually does two things. It runs two commands. This is, first of all of this is Nix code, and this embedded thing here that starts with the double quotes and goes over here 2 lines, and then another one starting here and ending here. This is embedded bash, and each of those bash scripts is basically a build step. So in Nix it gets modeled as what's called a derivation, and so this ends up as a precise build instruction where all of the dependencies are precisely defined, and then it can be executed as a build step basically inside of a sandbox. And the way we express dependencies here is, if you look at those two things, they are both declared in a let expression, which is not that relevant. It's just we declare one thing and then we declare another thing, and the way they depend on each other is that the tested one depends on the built one by just referring to it. So since I use this built thing here that's defined above inside the tested one, Nix can figure out, okay, so I need to first build this, execute these steps, and then whatever falls out of here, I have to feed as an input to this one so that it can do its thing, right? And that's how you stitch those things together. So there's this magical $output variable that's defined inside this script, and that's the output path where the result of this thing should land. And in this case, we have an executable here that we build with GCC. And in the other case, we produce some, we run that executable and we put it in its output path. We run that executable, and then the output it produces we put into its output path, into this student output.txt file, which ends up in the output path of this tested derivation here. So we have two steps and they depend on each other. They also refer to, like the build step refers to GCC, so there's even a dependency that goes outside of this. So in order to execute this one, we first need to build GCC, and so Nix creates a huge dependency tree of things with those two nodes that we specifically defined in there. And now I will just run this. So I have some so it's not really explained this syntax or the code that I wrote so that this works out, because this is not a complete thing. It's just the part of the code that I wanted to show off. So I left some things out here, but I think as an illustration it works. And this now, since I executed this, it produced an output folder, and this contains some output. So let's look at that. So it says hello conflang. So this is what the output of that example program was. We can also look at that example program, example.c. Yeah, it prints hello conflang. So this was our first example and a working one. So I hope you have a rough idea of what's going on here. Now let's look at the first pain point here. So I have a very similar setup. The big difference here is that in the end there is a diff that gets executed. So we do the same thing as before, but in the end we compare the student output to some reference. And if I now execute this thing, we can see that it fails because the reference and the student output don't match up. And interactively on the command line, we can deal with this error fine. We execute the command, we see what's wrong, we fix the error. But then if you basically want to scale and say, oh well, I actually want my code to do this for 50 students, you need this to not fail so that it proceeds, and so that eventually it can give you nice outputs, right? Because you actually just want the build to go as far as it can and then give you the results and tell you what failed and what didn't. And the way to achieve this that I found was the following. Okay, so inside the bash file, we just say, oh, well, ignore an error here if it occurs. And then we can build the thing, which is what we wanted. But this produces a lot of clutter because a lot of things can fail in a scenario like this. And actually, what I'm interested in is being able to specify this on a different level, right? To say, hey, I want you to do a thing, and that thing could fail, and I'm happy to deal with that failure, but it would be nice to deal with that failure programmatically. Now, the next topic that I want to look at is build logs. So for this, we only need one build step to illustrate it. Again, we try to build a C program, and if we do that, we can see that it fails because this example file that we provide here is broken. And what we want to get at now as the output of this is we would like the log. We want to get at the log programmatically somehow, because interactively we already have the answer here, right? We invoke this and it failed and gave us the output. So if we add, we have to add our other workaround here so that it actually succeeds. And then if we print the logs for that, we see something went wrong here. But we would like programmatic access to that. So we have to somehow put it into the output, because regularly there is a special directory on disk where Nix stores the logs for all of the build processes that it goes through, and this is what powers this Nix log command. And but how is this available here, right? How can we get to that same log? Well, the way that I did it for the code that I wrote is actually so you can do output redirection and take the build output, take the standard output and standard error streams and redirect them to a file. And then if you build that, you do get a build log with the same contents. And then you can also do the same thing with the T command, which is nice because it gives you the output on Nix log, where we don't have anything now because we redirected that, and it also writes it to a file for you so that you can use it in other derivations that depend on this one. Yeah. Now, another thing that was an issue for me was timeouts. So I have prepared another example here, which is the first build step is building a C program, and the second build step is invoking that program with a large argument. And what that C program does is it accepts a number of seconds as a parameter, and then it counts down from that amount of seconds until it finally prints done. So if you give it a large amount of seconds as an argument, naturally this program takes a long time. We can see it's counting down now, and this will take forever. So what do we do about that? Well, the way I dealt with that issue is by adding a timeout command here with a timeout of, let's say, 5 seconds. And now if we invoke this, it should be done after 5 seconds because it just runs into that timeout. But again, this is something that I'm not doing this on a derivation level, but I really have to do this in Bash for the specific command that might time out. And yeah, I'm wondering if something like this would be possible on a derivation level, and what that might look like. Now, another topic that I had trouble with was the topic of personal data. So for my implementation, I tried to keep student data and other data just completely separate. So there is a separate Git repository for all of the student submissions, and a separate Git repository for the specific assignment, and a separate repository for all of the generic things that I want to reuse. So basically the tools that I showed to you. So what is the actual issue? Well, one issue is that anything that we build in Nix ends up in the Nix store. So under /nix/store and then some hash is where all of the outputs of the individual steps will go, and you can do garbage collection on your store, and then everything that's not referenced by anything will be cleaned up. But I don't really know of a good way to say, okay, now I want to get rid of all of the student data that I have in my Nix store if you get it in there. So what you can do is you can do things like say, oh, well, I will spin up this disposable machine, and I will let it do a bunch of stuff and just produce an output, and then I will throw this machine away and get rid of the problem that way. But that's kind of an easy way out, right? And so this was also something that I was having trouble with. Okay, so coming from these examples, the broader point that I wanted to raise, finishing up now, is what is the purpose of a build tool? And the obvious answer that comes to my mind is, well, it's for building outputs, it's for building artifacts. But I do think that auxiliary outputs like logs, warnings, performance metrics, and the ability to exercise control over build step, they are equally as important. And I did often feel like it was kind of roundabout how you would get control over these things with Nix. And I do understand why that is, because of how the tool works, and it's not a general purpose tool, and I wouldn't want it to be. But I do wonder if Nix could do something to better support those use cases without compromising the overall design. So this is the end of my talk. Thank you very much for listening. I do look forward to discussing this during the conference. I would be also very happy if you would send me an email before or after the conference to talk about specific things that I presented. And another suggestion would be, if you afterwards want to discuss these things further, maybe you take a look at the NixOS discourse and open a topic there. I will be looking out for that. And thank you very much for the opportunity.